I've reviewed hundreds of cybersecurity resumes, and 95% of the candidates can't answer one simple question in the interviews. Show me what you actually done. Here's how to fix that, guys. Today, I'm showing you the exact home lab setup that will give you real, demonstrable skills that SOC managers actually care about. This isn't theory, guys. This is the lab that separates candidates who get job offers from those who can't. And you can build this entire lab for free. So, guys, here's the brutal truth. The certifications, in theory, won't get you hired anymore. When I interview SOC analysts, candidates, I don't care about if you memorize the CEH. I care if you can investigate an alert, understand what happened, and tell me what to do about it. The skills gap in cybersecurity isn't lack of people. It's a lack of people who can actually do the work. This lab changes that for you guys. So, we're building a complete attack and defense environment that simulates a real enterprise network. We're building a Kali Linux as one of our attacking machines. Imagine this is your red team. We're building a Windows server as our victim. This is what you're protecting. Security Onion as our security incident and event management platform. Essentially, this is where you learn the detection. We'll also add Wazuh as our open source EDR, which is essentially endpoint detection and response tooling. And we're also adding OpenVAS for vulnerability scanning. Everything connected on a virtual network where you can attack, detect, and investigate as well as respond. This is what real SOC work looks like. Normally in interviews, guys, you'll be asked, how do you investigate suspicious process? Walk me through analyzing a security alert. How would you respond to lateral movement? With this lab, you don't guess. You say, let me tell you exactly what I did when I simulated this attack in my home environment. I've hired analysts who had this experience over candidates with twice the certifications, but zero hands-on skills. This is, guys, your competitive advantage to land your first cybersecurity role. Now, here's what you're going to need, guys. If we talk in hardware, any modern computer with at least 16 gigabytes of RAM. If you can do 32, that is better, but 16 will suffice. Yes, your gaming PC works perfectly fine. If we talk in software, we need VirtualBox or VMware Workstation Player, which both are free. Now, we're going to need to download some of these operating systems. So we're talking Kali Linux. You can download that free from kali.org. Security Onion, again, free from securityonionsolutions.com. Windows Server Evaluation. You can get free 180-day trial from Microsoft. Wazuh, which is an open source EDR. Again, OpenVAS, an open source vulnerability scanner. Total cost, absolutely zero, guys. Everything you're using is free and has free evaluation periods. Now, let's talk about architecture. Before we build, we need to understand the architecture. So the network setup is, we're creating an isolated NAT network in your hypervisor. Think of it as a miniature enterprise network that can't touch your home network or the internet unless we want it to. So the flow is, Kali Linux launches attacks against Windows Server. Windows Server generates logs and security events. Security Onion collects and analyzes those logs as a SIEM, which I mentioned earlier, Security Incident and Event Management Platform. Wazuh EDR detects suspicious behavior on the endpoint. You investigate everything from Security Onion console. This mirrors how real enterprise security works. Attack surface, logging, detection, and investigation. So guys, let's build this thing. Step 1, the hypervisor setup. So what you need to do on your machine, you need to install VirtualBox or VMware. I prefer VirtualBox for myself for stability, and VMware is perfectly fine, but I've used VirtualBox myself. Now, step 2, network configuration. You need to create a NAT network called CyberLab with subnet 192.168.100.0/24. This isolates your lab from your home network. Now, why does this matter, guys? Well, in real SOC, you need to understand the network segmentation. You'll be working with VLANs, DMZs, and isolated security zones. This teaches you the foundation. Now, I want to preempt you guys. I'm not going to walk everything step by step. The goal is here, guys, to guide you through the whole setup. But I don't want to hand everything on a plate, guys. You need to understand and you need to figure it out, these steps for you, because you're going to learn so much more following this guide, guys. So, step 3 is security onion. We need to do a VM resource allocation. So, we're going to allocate 4 vCPUs and 12 gigabytes of RAM. This is your heavy hitter. Windows Server, we're going to do 2 vCPUs and 4 gigabytes of RAM. Kali Linux, 2 vCPUs, again 4 gigabytes of RAM. And Wazuh, if you're doing it separate, 2 vCPUs again and 4 gigabytes of RAM. Now, this total is over 30 gigabytes of RAM. But you guys can adjust this based on your total RAM allocation. You can run these sequentially essentially, if your system can't handle all at once. Now, build section number 2 is Security Onion is going to be your detection and investigation platform. This is where you'll spend most of your time as an analyst. You're going to deploy Security Onion on your virtual network. Choose a standalone mode for home lab. Set management interface to 192.168.100.10. Configure to monitor interface to see all the network traffic. Now, why are we using Security Onion? It's what small to mid-size organizations, SOC, actually use. It includes Suricata IDS, which is incident detection software. It includes also Zeek for network monitoring. It includes Elasticsearch for log storage and Kibana for visualization. It's the coolest free tool for enterprise SIEMs like Splunk and QRadar, but it's actually free. Now, initial configuration is you need to set up your first detection rules that enable the emerging threats rule set. This gives you thousands of pre-built detection signatures. In interviews, you'll be asked about your SIEM experience. Now you can talk about rule creation, log correlation, and alert triage using an actual SIEM platform. Now, step number 3 is your Windows Server is your crown jewel. This is what attackers want. So, setup, install Windows Server. 2019 or 2022 evaluation will suffice. Set a static IP address at 192.168.100.20. Join it to a domain. You can create a simple AD environment. Enable key logging. So PowerShell script block logging. Sysmon. So download Microsoft Sysmon config from Swift on Security's GitHub. Windows event forwarding. So why does this matter, guys? Most attacks target Windows, so you need to understand the event IDs. So you'll need to monitor things like event ID 4624, which monitors successful logins, event ID 4625, failed logins, event ID 4688, which monitors process creation, and event ID 4672, special privileges assigned. It's all common vulnerable software, for example, an old Apache version, an outdated SQL server, make this server realistically vulnerable. That's your training ground, guys. Now, install a few legitimate applications as well. Have it generate normal activity, right? Real investigations aren't clean. You need to find attacks within normal business operations, guys. Now, how to set up the log forwarding. This is where it gets real, guys. We're pushing Windows logs to Security Onion. So what you need to do is you need to install WinLog Beat on Windows Server, configure it to forward your Security Onion's log stash to port 5044. Specify which event logs to forward. So security, system, application, PowerShell, and Sysmon. So the configuration tips here are: you need to output to Security Onion IP, send security logs, Sysmon logs, PowerShell logs, buffer locally if connection drops. Now, go to Security Onion's Kibana interface, create an index pattern for Windows logs. You should see events flowing in real time. Now, why does this matter, guys? In a SOC, you'll work with dozens of log sources. Understanding how to onboard the new data sources is critical. You need to know things like which logs actually matter, how to parse them correctly, how to enrich them with context, and practice adding different log sources: IIS logs, DNS logs, firewall logs. Each one teaches you something new, guys. Now, how to build a Wazuh EDR. Now we add one endpoint detection and response. So Wazuh deployment, you can install Wazuh Manager on Security Onion, which is your resource efficient. Option 2, you can create a separate Wazuh VM, which is a cleaner separation. You can deploy Wazuh agent on Windows Server and configure it to monitor file integrity on critical directories, detect rootkits, monitor registry changes, scan for vulnerabilities, and detect malware through Yara rules. Now, the integration is: you can forward Wazuh alerts to Security Onion for centralized visibility, guys. When you run an attack, Wazuh will detect suspicious process behavior before your SIEM might. This teaches you the difference between network-based detection and endpoint-based detection. Critical knowledge for any SOC analyst, guys. You'll learn how EDR complements your SIEM, what endpoint telemetry looks like, how to investigate suspicious processes, and how to track lateral movement, guys. Now, the last build section is how to build Kali Linux, the attacker machine. It's time to become the adversary, guys. Deploy Kali Linux on your CyberLab network. Again, create a static IP address. This time you can add something like 192.168.100.50. Now, you need to update all the tools. So you need to run a command such as sudo apt update and sudo apt upgrade. I'll put it up in the top so you guys can see. Now, the essential tools in Kali Linux are: you got Nmap for reconnaissance, Metasploit for actual exploitation, Responder for credential harvesting, and PowerShell Empire for post-exploitation. You also grab Crack Map Exec for lateral movement. Now, why you would attack your own infrastructure? Well, because you need to understand, guys, what attacks looks like from defender's perspective, which attacks generate logs and which doesn't, how attackers think and operate, and what normal versus malicious looks like. This is purple teaming done at home, guys. You're both the red team and the blue team. And also, last but not least, let's add vulnerability management. You can also install OpenVARs. So OpenVARs, now called Greenbone, you can install that on a separate lightweight VM or on your Kali box. And then you can create your first scan. So obviously we set up Windows Server IP address. So now you can run the scan on the target IP address. You can, for example, run an authenticated scan first, then run credentials scan using local admin and compare the results. What you'll learn is, guys, the difference between authenticated and credentialed scan is massive. You'll see missing patches, weak configurations, unnecessary service, and default credentials. Now, practice remediation, guys, as well. Don't just scan things, fix skins as well. Patch the server, disable unnecessary services, harden configurations, then rescan and verify to make sure that they're no longer there. This teaches you the vulnerability management lifecycle that every SOC analyst needs to understand. Guys, now the fun part begins. Actually using this lab. So here are some of the scenarios, guys, for you to practice. Exercise number 1. credential harvesting. So run responder on Kali to capture NTLM hashes. Windows Server makes SMB requests. Detect this in Security Onion. Look for LLMNR, NBTNS traffic. Investigate the captured credentials in Wazuh and document your findings. Exercise number 2 is exploitation and detection. You can use Nmap to scan the Windows Server, find vulnerable service and exploit it with Metasploit. Watch your SIEM light up with alerts. Investigate in Kibana what IPs, what ports and what patterns do you see. And use Wazuh to see the endpoint perspective, guys. Now, exercise number 3 is lateral movement simulation. Gain initial access on Windows Server and use PowerShell Empire for C2. Attempt to move laterally, even if in your small environment. Detect the suspicious PowerShell activity in your logs and trace the kill chain from initial access to lateral movement, guys. Exercise number 4 is malware detection. So you can download now, there is a file called ACAR test file, which is essentially a safe malware sample. Transfer it to the Windows Server and watch Wazuh detect it. Investigate the alert and practice containment response. Now, exercise number 5 is create a baseline of normal activity. So we're going to do a log analyst deep dive. So baseline activity, run an attack and practice finding the needle in a haystack. Write detection rules for what you found. Exercise number 6, incident response. So when you detect an attack, contain. So isolate the affected system, investigate, which is essentially looking at a timeline reconstruction, remediate, remove the malicious artifacts, and document, write up your findings. So practice writing incident reports. This is what you'll do daily in your SOC operations center. So let's be clear, guys, about what this lab teaches you. It teaches you technical skills such as SIEM operation and log analysis, endpoint detection and response, Windows security event analysis, attack techniques and TTPs, vulnerability assessment, network traffic analysis, incident investigation methodology. Now, alert triage workflow. The practical experience is here, is the alert triage workflow, false positive identification, threat hunting basics, tool configuration and management, log source onboarding, and detection rule creation, guys. Now, this gives you the great interview ammunition. Every exercise becomes a story you can tell. I simulated a credential harvesting attack using Responder and detected it by analyzing abnormal LLMNR traffic patterns in my SIEM. I built detection rules in Security Onion for suspicious PowerShell execution by correlating process creation events with network connections. I investigated a simulated ransomware attack by analyzing file integrity monitoring alerts from Wazuh and tracking the encryption pattern. This, guys, what gets you hired. Now, do you want to take it further? Here's what to add, guys. Add an Ubuntu Linux server for Unix log analysis. You can deploy also pfSense as your virtual firewall. Add a web server with DVWA. It's called a Damn Vulnerable Web App. Create multiple domain users and simulate real user activity. You can also add advanced detection, so you can integrate MITRE ATT&CK framework in your detections. Build detection rules for specific techniques. Practice threat hunting methodologies and create custom Yarrow rules. You can also practice automation, so script common attacks with Python, automate log analysis with scripts, build automated response playbooks, use SOAR tools like the Hive and the Cortex. And also you can practice some purple team scenarios. You can document everything as a purple team exercise. So attack technique, detection method, response procedure even, and lessons learned, guys. And the most important thing here is, guys, the documentation habit. This is critical. Document everything in a portfolio. you need to create your GitHub repository with your configs, Medium articles about specific attacks you simulated, LinkedIn posts sharing what you have learned, create a dedicated website showcasing your home lab. This documentation becomes your portfolio that works for you 24/7. And here's what I tell everyone that builds this home lab. Building this takes possibly a weekend. Mastering it takes months. Don't rush, guys. The people who get hired aren't the ones who set it up the fastest. They're the ones who spent 100 plus hours practicing real scenarios. Now, the common mistakes that people do is building it but never using it, running attacks without investigating them properly, and not documenting your work. Focusing on quantity over quality. One attack, 20 different ways, guys. What hiring managers want to see, guys, when I interview candidates, here's what impresses me the most. The deep understanding of one attack chain, ability to explain detection logic, understanding why certain logs matter, and knowing what good versus bad looks like. Humility about what you don't know combined with proof of what you do know. A candidate who can walk me through a well-understood attack investigation beats someone who lists 50 tools they've used any day. Now, the harsh truth is, guys, this lab doesn't guarantee you a job. What it guarantees is that you will have demonstrable skills when you interview. The rest is on you. The communication, the professionalism, continuous learning, and networking. But this gives you the foundation that 95% of the candidates don't have, guys. So start building this today, guys, not tomorrow. Your action plan is download VirtualBox and Kali Linux tonight. This weekend, deploy Security Onion and Windows Server. Next week, run your first attack and investigate. Document everything you learn and share your progress on LinkedIn. I'll drop the links in the description of all the resources and where to find them, guys. But, guys, join my community, subscribe to my YouTube, where I'm going to share some more of the future projects. Follow me on TikTok. Again, I'll drop in the links where I drop daily cybersecurity knowledge every single day. My challenge to you guys is 30 days from now, can you explain how you detected a lateral movement attack? Show me the logs from an investigation you did. Walk me through your SIEM setup. If yes, you're already complete for SOC positions, guys. And I'll leave you with this, guys. The skills gap isn't the lack of jobs. It's the lack of people with practical skills. This lab closes that gap for you guys. Build it, use it, document it, and get hired, guys. Drop a comment below with what you're most excited to learn. I respond to every comment, and I'm here to help you guys succeed. If this added value, smash that subscribe button, guys. I share unfiltered cybersecurity career advice every week. The stuff nobody else will tell you about. Now, stop watching, guys, and start building. Your future SOC analyst job is waiting for you guys. Stay safe.